Hello Internet, my name is Fahim and today we shall see how we can implement the DFS algorithm in C++. So let us begin. First let's see what is the DFS algorithm. So very short, this is the actual DFS algorithm. You can see the algorithm here, and I'm going to implement this algorithm into C++. After that, what I'm going to do is implement that code, run that code with this on this example graph that I found on the internet. However, I've made some modifications. For example, these ABCs will be known as 0, 1, 2, 3. So these are the corresponding edges, and the output should look something like this. Okay, and so that's pretty much like it, and I shall explain what I have done in my code. So this is the actual code that I've written. I have a graph.header file and source.cpp file. Okay, so the actual code is inside here. Let's see what we have. So see that here we have these circles. The circles are known as vertex or node. Okay, so in order to represent those circles, what we need is a class. That's why I've written the class vertex, or if you like, you can rename it as nodes. Okay, so obviously our class will have some important properties or some elements. So there are n represents this number 0, 1, 2, 3, 4, 5. After that, what we need is a color, because the algorithm has a property called color. Then we need to have the parent, and also we need to find out the discovery time and finishing time, and that's why I have two variables, d and f. Okay, sorry, two elements, d and f. After that, what we need is a constructor. So this is the constructor, and I've initialized the elements, all these elements with some specific values. So this covers up some of the lines, for example white and null. See that I've made the color white and null. So color white and parent -1, null will be -1 here. So now that we have all these circles, what we now need is a graph. We need to create this graph. For that, we can use either matrix. We can either use a matrix or we can use a linked list. Okay, so in this case I've used a linked list. Okay, so this is what a linked list looks like, and in order to represent that graph, what I have done is written a class, okay, named graph. So it has an element pointer, vector integer type pointer a. Then I have this vertex pointer vertex, this type class pointer, and finally I've taken a result vector. Okay, so our output result will be saved over here. After that, I've taken v and e. So v indicates the number of circles. See that we have total 9 circles here, or 9 nodes or 9 vertices, and we have 10 edges here. So these numbers will have to be saved here, and after that what we need is this variable time. Why? Because in the actual algorithm we have this. Okay, so now that we have taken some elements, what we need is a constructor. Okay, so graph v0 e0 I've taken the number of vertices and number of edges. Now that I have the number of vertices, I can initialize this A. Okay, so what this line means is that previously A had nothing, so A is over here and it had nothing. But now that I have written this line, what it means is that A has now something like this, okay, which represents, this just this single row. There. Oh. There you go. So now I have this part of the linked list representation. After that, I've taken this one. What it means is that, remember this pointer over here. So previously the vertex had nothing. Now the vertex looks something like this. It is an array. After that, I've just initialized the numbers. That's why I have this 0, 1, 2, 3, 4 in this array. Okay. Following this, time equals to 0. Okay. Because the actual algorithm, see that time equals to 0. So this part has been done. Now what we need is the destructor, okay, because C++ does not support some garbage management system, okay, like Java does. So it is the duty of the programmer to manually remove the garbages or the allocated memories, and that's why we need to since we have allocated this memory and this memory, we have to delete them manually. So first I have deleted this one, then I have deleted vertex. So see that? While AI is not empty, what it means is while we have some elements here 4, 3, 1, I shall start popping. So AI pop back. So what this means, and this will run for I equals to 0 to v. So after running this for loop, we shall have something like this. Therefore, we can now delete them. That's why delete AI and delete vertex. So A and vertex, they're safely deleted. So after that, what now starts the actual algorithm. So see that we have a DFS method. Inside we have for if these 3 lines. Exactly the same lines have been written here. See that? For, then if the color is white, run the DFS visit method. So after that, we shall implement this method. Okay. So DFS visit u. What is DFS visit u? Oh, we have one extra line over here because I'm saving the result inside this. See that? Vector result. I'm saving the output inside this. So after that, the actual algorithm starts, which is these lines. So first, time plus plus, we save the discovery time, and then we change the color to gray. Just the first 3 lines. Exactly what they have done here. Time plus 1, then ud equals to time, u color equals to gray. Next, for each v belongs to adjacent of u. So if the color is white, phi pi equals to u. Okay, and then DFS visit v. So this is the part that you need to understand. So let's go here. Let's just say okay, what we need to do is okay, let me take my paintbrush. So at first u equals to 0, right? See that? Okay, u equals to 0. So for each phi adjacent to u, that means for phi equals to 1, 3, 4, this one, and this one, we shall check if phi dot color equals to white. I'm going to set the pi parent equals to u and DFS visit that vertex. Okay, so for 1, I'm going here. If the color is white, which is true, we shall make the pi is 0, and then run the code for we shall call this DFS visit on phi. So now u is equals to 1, and therefore 0, 2, 4. Okay, so 0, 2, and 4. Now we find that 0 is already gray. Okay, so it won't go inside 0. Okay, it will go to 2. So for 2, we shall write down pi equals to 1, and so on, and then call the DFS visit 2. That's why u will become 2, and we shall go here. See that 1, 5. So 1, 5, and since 1 has already been discovered, it was previously made gray. So when I come here to find 1, I see that 1 has been discovered, so I don't take 1, I take 5. Is 5 discovered yet? No. So I mark it with, since I'm discovering it now, I'm marking it with gray and setting the pi equals to 2, I think. Yes, and that's how it runs. Okay, so that's how these loops go like that. And after this, when this has been done, what we'll do is u dot color equals to black. So we'll just get back here, make the color black, black. Eventually all of them will become black, and we shall also get our finishing time and discovery time for all of the nodes, and that's how the algorithm works. So after that, just these 3 lines, exactly these 3 lines. See that? Set the color black, time plus 1, and time. Black, time plus 1, and finishing time equals to time. Okay, so that was the actual algorithm. Now we need some auxiliary methods. For that, I have written this DFS result, which will display the corresponding node, discovery time, finishing time, and parent. just a simple for loop and the elements here. Then DFS traversal result, what it does is that it will show you the output of this graph, this serial order of traversal 0 1 2 5 4 6 3 7 8, and finally what it does, LLG, a linked list graph printer, what it does is that it prints the it should print this stuff. Okay, and finally we go to the source program. See that we've taken inputs for text and edges, then we have taken a graph typed object and initialized with phi and e. After that we have taken the edges as inputs and set those edges. See that au.pushback phi, a_phi.pushback u. So what this for loop is doing is that it's creating this thing. Okay, so this is created over here by that for loop. Okay, sorry. After that I've called the LLG printer. This will print out this thing, the graph of our code. After that I shall run the DFS algorithm, then get the DFS result, and finally I shall get the DFS traversal, which is this result. So let us begin. I'll just build it, and now let's run the code. So 9, 10, that's the number of vertices and edges, and I've just saved the edges, so I'm just going to copy and paste them and hit enter, and Viola. So see that this is the graph representation, linked list representation of the graph. After that you can see is that which is the corresponding node, its discovery time and finishing time and its parent. So for the node 0, let me just open up this image here. So for the node 0, since it is the starting node, it has no parent, so it's -1. Okay, and then sorry, after that we go to node 1, which is this one. Its discovery time is 2, its finishing time will be 17, and its parent is 0. Then we go to node 2, which is this one, something like that. So and one more thing, let me show you. I'm taking a screenshot and don't save. Paint. So what I'm going to do is show you what is happening in the graph. So I'll just take my paintbrush. So first, okay, so this is what is this I've explained. I'm going to show you what this DFS traversal means. Okay, so see that 0 to 1, so starting from here we're going here, then 2, so here, then 5, which is here, then we are returning back to here, then here, then we find this path, so we go here, then we go to 6, which is this one, then we go to 3, then we come back, finally we come here and here, and that's how it's working. The order of traversal is 0 1 2 5, then 4 6 3, and finally 7 8, and that's how it works. Okay, Oh, and finally, that destructor function has been called, and so the allocated memories were freed, and that's how it works. So that's it for today. I hope you enjoyed the video, uh, and if you have any questions, let me know in the comment section. I'll try my best to answer them. Thank you.